Hi and welcome to my calculus clinic. This is Dr. Ghada Nakla. Today we are going to look at applying the product rule, and the product rule is one of the rules that we use to differentiate. So let's take a look at the first example. Y equals x to the 4 cos x. Now, in this case, we are going to use the product rule. And the reason why we are using the product rule is because x to the 4 is a function of x, and it is multiplied by cos x, which is another function of x. And product in mathematics means multiplication. So if we're multiplying a function of x by another function of x, this is when we use the product rule to differentiate this function. Okay, and we do that by saying let u equals x to the 4, let v equals cos x. It doesn't matter which is which, so let one of those functions be u, and let the other function be v. Okay, and then we differentiate those. We find du by dx. And how do we differentiate x to the 4? It becomes 4, and then we decrease the power of x. 4 minus 1, which is 3. So it's 4x cubed. And then we find dv by dx. We're differentiating with respect to x. And as you might already know, this is sine, which is the positive y-axis. This is the positive x-axis, so it's going to be cos. This is the negative y-axis. Sine is here, so minus sine will be on the other side. And if cos is on this side, this is the negative x-axis, so I'm going to have a minus cos. And you differentiate this way. So you differentiate sine, you get cos. You differentiate cos, you get minus sine. You differentiate minus sine, you get minus cos, and the circle goes round. Okay, and in this case, we are differentiating cos x. And when you differentiate cos x, you get minus sine x. Okay, and then we the product rule means multiplication. Product means multiplication in mathematics, and we are multiplying. So we do a cross sign here, which is the multiplication sign. Therefore, dy by dx, which is the derivative of x to the 4 cos x, is equal to, you multiply those two. So you go x, let's start this way, 4x cubed cos x, which is 1 multiplied by the other, plus, and in this case, I'm going to go minus because of this minus sign, x to the 4 sine x. And that is the derivative of x to the 4 cos x. Another way to look at it is the first multiplied by the derivative of the second plus the second multiplied by the derivative of the first. And if you apply this one here, you will say you will find that 4x cubed is the derivative of this multiplied by cos x, which is the second one. So the derivative of the first multiplied by the second, plus x to the 4, which is the first, multiplied by minus sine x, which is the derivative of cos x. Okay, so either way will be fine. So let's take a look at something slightly harder, at example 2. And let's take a look at, obviously you can simplify this. You can take x cubed common factor if you want to, but we're not really interested in this. We just want to learn how to differentiate using the product rule. And then you can use your skills to simplify. Okay, let's take a look at something slightly harder. We want to differentiate y equals root x ln x. Again, we do exactly the same. Let u equals first, we are going to differentiate using the product rule. And why? Because it's a function of x, root x is a function of x multiplied by another function of x. And that's when you use the product rule. So let u equals x to the half, and x to the half is root x. I'm sure you know that. And then let v equals the other one, ln of x. Doesn't matter which is which. You can go u ln x, v x to the half. It doesn't really matter, because at the end we're adding, and when you add it doesn't matter. Okay, so we differentiate du by dx. You drop the power, which is a half, drop it down there, and then decrease the power of x. When you differentiate, you decrease the power of x. When you integrate, you increase. In this case, we're differentiating, so we're decreasing a half by 1. So a half minus 1 is minus a half. Okay, and then we find dv by dx, and the derivative of ln x is 1 over x. Again, we cross multiply here. So dy by dx, which is the derivative of the function of the y, which is a function of x, is equal to, and it doesn't really matter which way you start. Let's go x to the half multiplied by 1 over x plus a half x to the minus a half ln of x. And that is the answer. X to the minus a half is the same as 1 over square root x. You can simplify it. And again, you can simplify x to the half multiplied by 1 over x. You can always simplify it. But for the sake of the product rule, we're only looking at the product rule. You can simplify it much. Okay, let's take a look at something slightly harder. Example 3. And let's take a look at y equals x squared e to the 3x. Again, x squared is a function of x, e to the 3x is a function of x. A function of x multiplied by a function of x, it means product. We then use the product rule to differentiate. We let u equals x squared, let v equals e to the 3x. It doesn't matter which is which. We then differentiate u, so du by dx is, drop the power, x, decrease the power. So when you decrease 2 minus 1 is 1. So 2, there is an invisible 1 at the top there. I'm not going to put it, I'm not going to write it, of course. Okay, and then you find dx, dv by dx. When you differentiate e to the x, it stays e to the x. It stays the same. When you differentiate e to the kx, you get ke to the kx. Okay, so when you differentiate e to the kx, you get ke to the kx. In this case, k is 3. Okay, so we get k, which is 3 e to the kx, and in this case, it's 3x. So 3 e to the 3x. Again, we multiply, cross multiply, and then you find dy by dx, which is the derivative of the function, is equal to, where do we start? Let's start from this side. So 2x e to the 3x plus 3x squared e to the 3x. It doesn't matter how you write it. We can take x e to the 3x common factor. We're not interested in simplifying. We're just interested in applying the product rule. Okay, let's take a look at something slightly different. I think we're number 4 now, and let's take a look at y equals x e to the 2x. Again, first thing we do is let u equals one of them, which is x. Let v equals e to the 2x. Let u equals one of them. Let v equals the other one. And then you differentiate, you find du by dx. And when you differentiate x, you drop the power. There is an invisible 1 here, so you drop the power, which is 1, x to the 0, and x to the 0 is 1. Anything raised to the power of 0 is 1. And then dv by dx, e to the kx differentiates to k e to the kx, and k is 2, so 2 e to the 2x. Again, we cross multiply and we go dy by dx equals e to the 2x multiplied by 1 plus 2x e to the 2x. And again, I can simplify it further. I can take e to the 2x common factor, but I'm not really interested in doing this now. Let's take a look at a different example, and let's go y equals 2 root x ln x. What's my starting point? Exactly the same as all the other examples. Let u equals one of them, so 2x to the half. Let v equals ln x. du by dx is equal to 2 multiplied by, drop the power, which is a half, x, and then decrease the power. You decrease the power by 1, and we've done that earlier on one of the examples. It becomes minus a half. And dv by dx is 1 over x. Oops. Sorry about that. It differentiates to 1 over x. Again, we cross multiply. So we find dy by dx, which is equal to, we can simplify those, of course. So we end up with 2x to the half multiplied by 1 over x plus x to the minus a half ln of x. And again, we can simplify it further, but let's focus on the applying the product rule. Okay, let's take a look at something slightly different. And we're on example 6 now.